Good morning and welcome to the new PMTS venue in Cleveland, Ohio. My name is Greg Knight and I've been in the machining industry for 40 plus years. I owned the screw machine job shop for 20 years. We had brownies, cones, CNC lathes and mills, and a whole lot of secondary equipment. I spent 15 years in applications, marketing, and sales for the ServoCam product, and the last five years actually as the Leico North American importer and distributor. 2 years ago, we sold our Leico import business to Absolute Machine Tools. Absolute has been an importer of CNC machine tools since 1988. And I now work with Absolute as the Vice President of Sales in the Production Turning Division. Phil Jutt has spent 23 years in the machining industry, completing his tool and die maker's apprenticeship. Phil has also spent 2 years as an applications engineer with Citizen Distributor and worked for 17 years in various job shops on CNC lathes, CNC mills, and CNC Swiss. Phil has been an applications engineer at Absolute Machine Tools for 2 years in the Swiss and CNC screw machine area.
All right, my turn. Well, good morning. I'm Phil Jutt, and what I always look at is, since Swiss came on the market and has been developing, everything seems to be a Swiss part because of its productivity. And sometimes when Swiss is the answer, it's the only answer, it's the best answer. And a lot of those situations are, of course, you got a long length to diameter ratio, you have a small part with a lot of milling, live tool work, and when those situations happen, of course, we want to tell you that Absolute does carry the Nexturn line of Swiss lathes, Korean built. We can meet you in those needs, we can help you out. And we can cover everywhere from 7-axis to 11-axis, keeping 3 tools in the cut. We have that capability. But what we want to talk about today is when that isn't always the best answer, because we have some unique platforms that you may not know about that can be more productive than a Swiss. And what I found in my experience, when I was in a job shop, I worked on 2-axis lathes, and then we brought a Swiss into the shop, and like most of you, all the work started moving onto the Swiss. And everyone got their 20mm Swiss, they filled it up, and then, okay, well now we have some bigger works, now we get a 32mm Swiss, and that gets filled up, and it's proven, it works. And then the Swiss makers have brought the non-guide bushing capability or chucker mode capability, and now we're thinking, oh, now we can do 38mm Swiss, now we can do 42mm Swiss. Well, calm down, because we still got those little ball screws pushing around all this material. We can't move material as fast as we can with a fixed headstock lathe. So that's where I kind of want to go with this and tell you about. We do have the Nexturn line. Again, not saying Swiss isn't always the answer. We can help you out when Swiss is the answer. When Swisses came on, Traub, Index, they had good products, have good products, and the Swiss were a flexible solution for small and large lot sizes. But again, like I said, as you get larger and larger work, I think we have something better. Of course, if you only bring Swiss to the market, the answer is always a Swiss, and that's what we want to tell you about. But it may not be the most productive. And when you have a lot of metal removal, you got big drills, you got to turn a lot of material off, we can do something for you that's different. And I find the recipe, whenever I put a part together, the recipe that changes is about 20mm. Smaller than 20mm diameter, it's hard to beat a Swiss. But larger than that, with our different platforms, I think we can do something different. And yeah, you already know that larger capacity machines, now you're putting a turret on there. So now instead of a half-second chip-to-chip time that a Swiss can do, you're looking at 3 seconds, 2 seconds, chip-to-chip, at best. So even having the fixed headstock doesn't always equal better productivity or more parts per hour, or more parts per 24 hours. But what we do with our unique platforms, we do it differently so that we can beat that chip-to-chip time. We can get you more productivity on the larger lathe. And Greg is going to tell you about that.
Thank you. So Leico began producing cam-operated screw machines back in 1978. QuickTech's been producing machines since 1996. What Leico learned in producing cam screw machines, they brought to the market when they produced their CNC lathes. They began work on this model, the LNTS, in the early 1990s, first introducing it to the USA in 2006. So this is this model, and unfortunately I just discovered laser pointers won't work on this, so I'm going to try to, without being in the road of everyone, just point out a few things. So these slides right here are dovetail and gib slides. They're not boxways, they're not linear guides. Dovetail and gib slides mean you can hang a form tool on there if you want to. They're much more rigid, and they're that way in the X and the Z. These machines have 4 cross slides around the spindle. You get an 8-position turret. You can have live tooling in any position. You can put gang tools for the static on any of those positions, and they run with a turret-mounted pick-off device for backworking. So the point is, they can drop parts complete. They were engineered to produce parts that were once produced on single and multiple spindle screw machines. And they really have been productive workhorses. We have customers who are beating their production even from their servocam ultra-turn Brown & Sharps, which are 20 to 30% faster than a cam-operated Brown & Sharp. So it's kind of a big deal. Some customers have been able to become more productive on these machines also, even from their multi-spindle machines. And usually that's because of setup time issues and diminishing lot sizes on the multi-spindles, but sometimes because the multi-spindles run so fast, the machine utilization rate is down because half the time you're stocking up the machine. You can put a bar loader on this and walk away and let it run parts. They're versatile and designed to hold up for production runs. They're also great for shorter runs with their quick changeover time. And we have some customers who, I was even amazed at this, but they swear they do. They run 3 different parts a shift, set up and run the production lot because they're only running 100 or 200 or something. So when you think about these platforms, think screw machine speed with the quality and versatility of CNC lathes. The LNDD machine, which is this one, is a little different than the other one I just showed you. We still have the dovetail and gib slides. It has an independent subspindle. It can be tooled front and back to work on the main and the sub. It can work on the main and sub at the same time and superimpose. And with the Y-axis, you can have dual, either static or live tools. But we've got holders where you can put 4 turning tools in there, so you can rough on the front, finish on the front, rough on the back, finish on the back. That's one tool position. On each of these machines, any tool position can be live. On this one, this can work on the main or the sub with the live tools. The most versatile build on this machine is with the live and 3 cross slides and a Y-axis turret. That's how this one is outfitted. Again, just to be clear, we're showing this, you can superimpose the sub with the main so that you can drill 1 feed rate into the main, be following with another feed rate on the back, and then have a couple of cross slides in there. That's how you get 3 and 4 tools in the cut at once. Customers have replaced low-running multi-spindle parts, low lot size, I should say, without sacrificing the cycle time that you might sacrifice to run that on a twin turret, twin spindle lathe. I'm still not saying it's going to run, no single spindle machine is going to run a faster cycle time than a multi-spindle. That's not going to happen, but as that lot size goes down, where you used to run 25,000 pieces and now you're running 1,500, the setup time alone can kill you. I've actually seen times when customers can set up and run their lot on this before you ever got set up on the multi-spindle if it's a complicated setup. With this platform, you can also draw complex and long parts complete. Moving on to the Quick Tech, and again, sorry about the laser pointer, but this has 2 gang slides, so it's the same as a twin turret machine, if you will. It's got 2 spindles. Each gang slide has the capability of 12 live X, Y, B, Z axis tools. So you've got a total of 24 live tools. This is a great alternative to the B axis on a Swiss. One, because it's economical, and 2, you got 49 total tools on this machine, which is this third machine right down here. Again, with the 12 live tools for each spindle, it's essentially a twin spindle, twin turret machine. It's just, it has gang slides instead. Now, lots of people look at that machine and they think it's a Swiss because it has the gang slides, but it's not. It's a fixed headstock machine, which means, again, as Phil just told you, in the larger diameters, you can have a higher metal removal rate. You still have a max on that machine of 2 tools in the cut at once, as opposed to 3 or 4 or 5 on these. It's really great for parts where you have a similar amount of machining on each end. These are probably a little better, where you can do a whole bunch of machining with those cross slides that you see here, and then finish up on the backside. The iRobo has an integrated robot, 6 OD, 5 ID static tools, and 6 live XYZ tools. The machine also has an option for the 12 live XYZB tools, and that's what's being shown there. The one that's down there has that feature. Now, we're not actually cutting any metal on that one, we're just displaying its robotic capabilities and loading and unloading. Again, with the live tool action, the gang similar, it's exactly like that of the iUltimate. Load and unload parts automatically with a fairly small footprint. Remove most of the labor costs to process secondary operations. You can load blanks off multi-spindles, forgings, castings, headed parts, sawed blanks, whatever you need to. Uses a Mitsubishi 6-axis articulated robot to handle a large variety of part shapes. You can flip the parts and machine both sides if the part configuration allows that. Has an optional multi-tray pallet stacker, so you can run it for extended periods of untended operation. It's really a complete solution for loading and unloading parts. The iUltimate, which you'll see cutting here in a minute, is an excellent choice when you need lots of live tooling on a fixed headstock machine. So it's really, especially on these 2 platforms, it's overlapping tools that does it. It's really that simple. The more tools in the cut, the faster your cycle times. We get 3 tools overlapped in almost every program we do on these machines. Many of them get 4. It's possible to get 5. I'm not going to tell you that's going to happen every day. It depends on the part configuration, as everything does. The part governs that. So let me show you an example. So this part actually started out being run on a single spindle cam machine, and then they're chucking it back up in secondary in it. They thought they'd hit the holy grail when they found out they could put this on a twin spindle single turret machine and drop it off done, so they don't have to chuck it up anymore. But they got looking at twin turret machines saying, well, we could do this a little faster. So they were dropping this off complete in 49.8 seconds. They were pretty happy with that until they looked at the twin turret machines. So they looked at that and they said, oh, gee, If we can move this sub-spindle down and overlap that, we can increase the productivity by 44%. They just kind of skipped over, by the way, the single turret, single spindle phase, because they still had to secondary the part. We were able to take this and not only move the sub-spindle work down here, we could move the rough drill, or the rough turn rather, and overlap with the drill, bring the finished turn down and start it in right behind the rough turn. So for a good portion of this cycle, we've got 4 tools in the cut at one time, and 83% is a whole lot better than 44. So sorry to be redundant about this, but again, there's no magic about these machines. It's just the physics. It's the overlapping tools. Again, all the slides on these machines, the turrets and the cross slides, are capable of simultaneous operations. So again, the implication here, 3 tools in the cut during the part cycle for 10 seconds takes 20 seconds out of your cycle time. 4 tools overlapped for 10 seconds takes 30 seconds out of that. I mean, it's simple math. And it's a simple concept. It's just the more tools in the cut at once, the quicker the cycle time is going to be. You're not pushing the tools any harder than you would on any other machine. It's just the design of the machine itself. With quick change over time and high machine utilization rates combined with the overlapping slides means increased productivity, more dollars in your pocket. Power of parallel. Check it out, ask any of our applications guys. You're going to see the demos here, but see if you can put it to work for yourself. So Absolute Machine Tools offers a full spectrum of services. In sales and engineering, we work to provide you a custom solution. Applications and training from people who have spent years working in the industry, and an experienced service team working to keep you up and running. Our brand promise is cost-effective engineered solutions guaranteed. So anytime you're evaluating a part, you've got lots of parameters to look at. There's a best solution in most cases, but you don't always have the ability to do that, especially as a job shop. You need a machine that might be versatile enough to do you some good here, but also do you some good over here on a different part. So you need something that will give you a broad overall productivity increase for a wide variety of parts. Now, if you have a long runner or you're a captive house, then we have the ability to hone in on exactly the solution you need and custom tailor that. Absolute has applications engineers who can assist you with time studies, with process comparison spreadsheets where we can compare disparate processes. We break them down into hours and dollars. And now, onto the machines.
I'm going to go down to the QuickTech i42 Ultimate first. And I'll show you the piece part we're going to do here. So on the main spindle, I'm turning and grooving. I'm going to drill a hole on the end. I'm going to use live tools to cross drill at 90 degrees. Use the B-axis to compound angle drill. And all while that's happening on the sub-spindle, I'm going to face it to length and break the edge. Going to counterbore, going to drill, going to tap. I think we lost my mic. Okay. So that's what we're going to do. So take a look in there. Got a good view. Okay, here we go. So on the main spindle, we're facing, we're turning. All the while the sub spindle is turning, and so we have overlapping tools, drilling simultaneous. Bore the counter bore. The main spindle still working on turning with that gang slide we talked about. We tap on the sub spindle while we're still turning up on the main. Now we're going to mill that hex on there using the X and Y axis on the sub. drill on the main with the live tools. Drill that compound angle hole. You see how our B-axis rotates. So for many applications, you may only have one B-axis hole. Well, this allows us to load a lot of redundant tools as well, if that's going to help your part process. We're going to eject the part on the sub and get it ready to go over and pick off. Oh, keep in there. Or come up and pull the part to length. And we're going to cut it off. And I always like to say I like my demos to show the capability of the machine. It can run faster, and of course we're running brass. We've run tough stainlesses all day, no problem. All right, so now we're going to move on down to the LNTS. This piece part we're making in here, I'm making this out of 1 5/8 brass. So on the main spindle, of course using our parallel machining, I'm going to rough turn, finish turn, spot drill, and drill through all at the same time. Then while I'm doing this grooving operation, my subspindle, my turret-mounted subspindle, is going to move to the back, spot drill and rotary broach this 10mm hex. Then it's going to eject the part, come back to the main. We're going to probe this diameter to verify my size. I'm going to roll thread and then reset the head on this 5/8 11 thread. Then I'm going to pull it to length and cut it off. We're ready to go. Yep, that looks good. Here we go. So we're turning and drilling simultaneously with different programs, different feed rates, all independently controlled. So I got 2 tools in the cut right now until my drill finishes up. Now it's going to move over. You see the turret-mounted subspindle. We're going to drill, rotary broach. And now the main spindle is using constant surface footage to do the groove while the subspindle is working. We're going to eject the part, wash out the subspindle, wait for my groover to get done, stop the spindle and probe. And again, we can integrate the probe to do whatever you want to check. Do a roll thread. That's right, reset that roll thread and pick off my part, pull it to length. Okay, now we're going to walk over to the LNDD here. This part, I keep on seeing people that make barb fittings, so I made a barb kind of fitting. So what I'm going to be doing is rough turning, finish turning, doing this barb feature, drilling on the main spindle, and drilling on the subspindle all simultaneously. Then I'm going to bore for my thread that's a 3/4 pipe, single point thread it, mill the flats, eject the part, pick it off. All right, ready to go? That's a good view. We're going to bump stop out to length. One, two, 3 tools in the cut. So once my rougher clears its first pass, now my finisher starts, 4 tools in the cut. 3 tools in the cut. Move over and bore. Still 3 tools in the cut. Oh, 4 tools in the cut again. So now we're down to 3, and I'm going to hold 3 tools in the cut for a while. Facing on the subspindle side while I'm still finish turning and profiling my barb. No single point thread on the sub. And we'll mill those flats on there. Turret can use live tools on either spindle. And my main spindle was just too fast. It's got to wait for this mill to get done. We're going to eject our part. All right. Now we're going to pick it off and cut it off. All right. So that's what we have to show you here today.